So I never really understood how the sun was red and how it made the sky red and stuff. And every explanation I saw didn't quite nail it. So I wanted to make an explanation of my own, but I'm not a graphic designer, so bear with me here. So basically, first of all, blue wavelengths do like this. Red wavelengths do like this. So blue wavelengths can hit things a lot easier. And by things, I mean air molecules. So pretend these big black things are air molecules. So when the sun shoots out all the wavelengths, I'm simplifying it, and shoots out the entire spectrum, but we're going to do red and blue. So just to be really simple. So blue, higher energy wavelengths hit the air molecules and bounce all into space and the ground and everywhere, and they just bounce all over the place. So if it's early in the day, then it's just going to bounce all around the sky. So like it's going to hit this molecule and then come to you, or it's going to come straight to you. So everything it hits is going to bounce off like a pinball machine, and from every direction. Let's say from over here, does the sky look blue from over here? Well, let's see. Bounces off this one and that one and that one and that one and that one, and then it hits you. So yeah, it bounces all over the place and they all come into you. The red ones though, they just kind of shoot on by, occasionally bouncing off, which is why when you're standing, let's say around here and you're an observer, the sky around you looks blue, the sun looks kind of yellow because there's more red than blue, which tints it a warmer color because it's not quite bouncing off enough, so it's just going straight to your eyeballs. But later in the day, there's a lot more air to pass through because when you're here, there's like this much air, this atmosphere. But when you're all the way over here on Earth, then there's a lot more atmosphere. So the blue just kind of gets scattered off and bye, down, or lands over here on the ground and people in the morning can see it. But there's not much over here anymore. So blue just kind of, it's just there now. However, the red scatters off more and comes back to you, and the sun appears a lot more red or orange or yellow or just warmer in general because that light is just coming straight to you with no blue interference. It's a lot less blue. So yeah, okay. So basically, this is the evening. So in the evening, there's a lot more air molecules than in the day. So there's a lot more air molecules. That blue just kind of comes down a little bit, but it bounces off a lot earlier. When all the red just kind of bounces around earlier and beams straight to you partially. So everything turns red, but mainly the sun. So you see there's a lot more air molecules. The red starts off kind of straight, but then it branches out a lot. And then it comes into you from all directions. Meanwhile, blue just spreads out and then just kind of doesn't reach you at all. Now, during the day, as you can see, because I've labeled that day, there's less air molecules, so they just kind of fly straight and straight. And then, oh, there's the atmosphere, so the red just kind of goes straight and bye-bye. And the blue scatters. So if you're standing like here, then the blue light could scatter off and off and off, and then it comes from that direction, then it bounces off here, comes from that direction, or bounces around, bounces backwards, comes from that direction. So it comes from all different directions. But the red only comes from the sun pretty much, which is why the sun appears to be tinted. So you see less air molecules, red just goes straight to you. Some of it bounces off, but mostly it just goes straight to your eyeballs, which makes it tinted warmer colors. Meanwhile, the blue scatters everywhere and spreads out evenly. Last slide of absolute chaos where I have no drawing skill. So let's say the sun is over here going upwards. So again, same visualization, just slightly different. If you're standing here, then that red is going straight to your eyes, which makes it warmer. Meanwhile, there's less blue. The blue just kind of goes all around the place. And then by the time it's evening and there's so much air, I mean, the red eventually does scatter with how much air has to pass through. And that leads to it eventually going all about. So, some, like a little bit comes off here and comes back there, and then a little bit comes off here. It builds up over time. Meanwhile, during the day, it doesn't. So there's kind of the only things that can happen. So either it can go straight to your eyeballs, it can go off, bounce out into the atmosphere, and bye-bye, there it goes. Or it can bounce off away from the direction of travel from the sun, but then bounce back towards you. That's why the sun doesn't appear white and everything else black. Because, let's say you're standing in this spot, if you're looking at the sun, you should expect the sun to beam blue light towards you, but then there's no light coming from here, just the stars, so space should be dark. However, it's not, because there's air molecules in the way, so it bounces off, and then it comes from that direction, and that direction, and that direction, and all the directions, which is why it appears blue. But when you're later in the day and the blue's mostly gone, then by the time the red has scattered out a lot, and there's still a little bit more, then it comes from that direction and that direction and straight from the sun, which makes everything appear red. So that is my extremely janky Canva zero graphic design skill explanation. I do think I did it better than most other things though, because they don't really get into the nitty gritty, as they like to say, of how the red, like the whole sky appears red later in the day. It's just, I never got a good explanation, even from like minute Earth or minute physics. Now just to be satisfying, just, it feels good. And then just drag all. Oh wait, no, I did not want to do that. It's kind of hard to do. All right, there we go. Boom. Oh, boom. Oh, nice. And get rid of all this trash. Clean. And let me just get rid of these pages too. Boom, gone. Boom, gone. All right, so that was my super janky, but in my opinion, pretty informative way of describing why the sun appears to be warmer and why later in the day it's more warm.